Hello, welcome. My name is Dr. Phil Winder, and I'm the CEO of Winder AI. Just before we get started, a little bit of admin. This presentation and the slides will be uploaded to our website in a couple of days' time, so make sure you subscribe to the newsletter to find out about that. We will try and answer as many questions as we can at the end. Feel free to add the questions to the comment section of the platform that you're currently on. And yeah, I think that's probably about it for admin. So I'd like to introduce Enrico Rotundo. He's my colleague working on a number of different projects at Winder AI. And one of them was a project for Stability AI, where we help them develop stable audio. He's going to be talking about a lot of the technology behind the stable audio product. So without further ado, Enrico, welcome.
Thank you very much for having me here today, Phil.
No worries. Okay, I'm just going to share your presentation. Feel free to crack on. And yeah, I might ask a few questions as we go through, so apologies for the interruption.
Sure, no problem. Just, yeah, go ahead. Raise your hand whenever you feel like. Hi, everyone. Well, this is Enrico again. So this is going to be a technical talk about essentially how we deployed and scaled models for generative models for StableAudio.com. They're Python models, so anybody that's interested in that, just please follow us. Yes, Phil introduced me already. I'm Enrico, and I do MLOps engineering for Winder AI. What is MLOps? Well, essentially, it is taking care of the full life cycle of your machine learning models, from essentially training your models, versioning your artifacts, scoring your performance, package that up, and ship that as a model in a deployment environment. Now. In the remainder of this talk, we are going to be focusing on this part at the bottom right and screen, and specifically, I'm going to talk about how we used NVIDIA Triton and AWS Sagemaker to achieve production-grade scalability. What is StableAudio.com? It is we call it music or audio generation platform. It's powered by a generative AI model, and it was launched by Stability AI back in September last year, and just recently, there has been a new update that brings on more features to the platform, but essentially your input in a very bare bone sort of version, you'll have your input will be a text prompt, and then you can generate your sound. I'll give you a demo in a minute. And so essentially this has been the first generative audio web app available on the market, and it has gained quite a lot of I would say tractions in the news. So it's being launched worldwide, and that resonated apparently pretty well with people involved in the music industry and music productions. Well, it's time to take a look at it directly. Well, so if you just head over to stableaudio.com, well, I've signed up already. You should do it too at some point. So you're presented with a suggested text prompt. I'm gonna just pick one from the sample library. So in this case, you can really just do your prompt engineering and then have fun. I'm going to select the V1 model. This is capable of generating 90 seconds of audio, and just hit generate. What's happening right now is that the backend sending over a generation request to the underlying ML infrastructure, which is the topic of today's talk. Hopefully, soon it will complete the processing, and I'll be able to play it. I hope the audio. Can you hear that?
Just about. It's coming through your mic, but we can hear that it's music. A sound, at least.
Okay. Well, hopefully, you can do more, but with this platform. But I'll let you to it, and just go ahead and have fun. Well, there is a free, tier, so you can just try it out for free. Well, let's go back to the slide deck. Hopefully, that'll give you the gist of the user-facing part of this system. So it is generative AI, and this slide actually pertains to just the V1 model, and it was it's proprietary, but you'll find some details on this blog post. Essentially, it's a very large generative model trained on more than 800,000 audio samples, and it counts more than 900 million parameters. It's a Python. It's a Python model, and it's a fairly large one, anyways. So, what does it take to deploy such a model at scale? So, in terms of MLOps, we faced a problem in quotes. Its model size was, beyond 20 gigabytes. In memory size, and it runs in the GPU for obvious performance reason. That entails requirement of NVIDIA drivers and such. So dependencies are rather complex. Inference, so the generation time, as you just saw, it's not instant, so it'll take some time to generate. So you'll just have to wait for it. Your code will be blocked until it generates the audio, and once it is done, its output. It's also fairly large because it just doesn't create an MP3. It will create essentially a NumPy array of integers representing your wave file. That's very large. It has to be post-processed. And yeah, also important note, this is launched worldwide in a matter of basically just flip the switch one day since mid-September last year, and that required a fairly large firepower to be provisioned, and I'll show you sort of the gist of it. So essentially, in brief, like deploying. So it's hard to so running this model and running its runtime, especially in the cloud environment, it's hard to reproduce. It's a hard problem, and also, we'll have to also take into account that it's non-instant processing type of compute. Yeah, and so because of that, some people might ask, like, why can't you just use a Flask API and wrap your model around an endpoint and ship it on a Docker container? Unfortunately, that's not possible because of the complexities listed above. If you just go for the Flask way, it will be a nightmare. So let's just not reinvent the wheel and use existing tools, open source, to achieve our goal. And a sort of a solution for our ML problems are essentially looking for a system that can package our runtime into a bundle, and also support asynchronous inference and deliver performance. How to tackle the worldwide launch? Well, you just need scale and in terms of number of instances that can run in parallel, but you also want to make sure that you're exploiting as much as possible your GPU power as well. This is let's get to the first component of our stack here. NVIDIA Triton. It's an inference server that it's open source, and it comes with a number of features that are solving these problems and that I just mentioned. So it supports dynamic batching, post-processing for your output, and will release the GPU. So this is very useful. When I mentioned what I mentioned earlier was to convert that raw NumPy array that represents some audio into an MP3, or like some further processing that could be achieved through the pre-post processing API of Triton. It has it comes with metrics, so it's good. It's sort of provides good observability for your deployments. And so it does. So basically, it will ask you to you're not going to ship a Docker container, but instead it uses a concept of packaging a runtime, which is, I'll show you more details later, but it's basically your source code and your libraries plus something else. And it supports a lot of backends for all your favorite ML frameworks, PyTorch and so on. So essentially, Triton is the component that allows us to sort of exploit a GPU hosts, vertically, and SageMaker is what allowed us to scale out horizontally, and by just allocating more instances. And this was the auto scale feature of SageMaker was very, very convenient to achieve that flexible scaling. So I'm going to focus a little bit on the last two, well, on the runtime packaging and on the a little bit and on what that means. So runtime packaging is, as I said, it's basically your Python code that you'll have to wrap with a given Python library, a Triton Python backend in this case. So it's a little bit more complex than just throwing a Flask endpoint at your model, but it gives you more flexibility, and it comes with pre-built features. Your dependencies will be specified in as a conda environment. So this was a fairly useful because it not only supported libraries, but also all system level libraries that we needed to support some type of audio post processing. And your runtime is also composed by the model weights, which are so in this case we're in the order of tens of gigabytes. And here the first sort of pain point comes. So what you do in order to send your runtime to Triton and then hand it over to SageMaker is you create a bundle, a compressed bundle through a conda pack utility, and this has been a very slow. So it's basically, if you have conda, it's notoriously slow itself. If you add that on top of the conda pack processing, and plus the tiring of the bundle, so this is it's been a very it's very slow process, and it can be a pain point. There could be a solution to these, but I'll show you later why that wasn't available to us for technical reasons. So once you get your bundle, and hopefully you want to test your models before you deploy, right? That's hopefully what you want to do. And in order to achieve that, you need to run on a GPU equipped machine. So let's say this is your local host, or in EC2 instance, where you basically you create your bundle, and you create and then you run a local Triton instance, and that that will let you test your code. Now, despite the firepower you can throw at it on this EC2 instance, so Triton is still fairly slow in sort of unpacking your bundle, your bundle and your runtime bundle, and loading your model weights, and preparing, warming up, such that you can get to a stage where your model can be actually tested. And this is very, it's not an instant process. It's fairly time consuming, and well, it requires quite some pain to go through. And but let's say you pass your tests and you want to deploy to AWS. This is where you want to, well, put your runtime bundle onto an S3 bucket, which can also be a slow process unless you're running on a EC2 instance. But if you want to send it across the wire from your office network, it will still take quite some time. And once your bundle is on within AWS premises, let's say, SageMaker can easily pick that up and run a Triton instance under the hood and create what they call SageMaker endpoint. This step is also proven to be fairly slow because some complexities in SageMaker, I guess, but it's also what I would call flaws, in the sense that we ran into this case a number of times where basically whenever there is a problem with your bundle, SageMaker will eventually fail, but that only happens. It will retry until some timeout goes off, and that will take you 10+ minutes just to get an error message. Hey, I couldn't load up your model. Please start again from scratch. Overall, just going through this journey can really take easily 30 minutes. And I think this is a major problem with the current ecosystem. I see at some point somebody will have to fix that. Now, I haven't mentioned automating this process yet. It's very complex to achieve. Basically have your CI/CD package up your bundle and ship it to S3, because your machine that creates your bundle and runs tests has to be nearly identical to the production host. So in this case, SageMaker endpoint, and this boils down to mostly NVIDIA drivers compatibility among other requirements as well. And it's also fairly complex to set up. So this is very hard to get. I think, we're not there yet. Also, so I mentioned about trials and tribulations, behind packaging a runtime and going through that journey. You can imagine that the Triton people created a solution for that, and in fact that is the case. But when we look at the ecosystem, you'll see this picture. So these features are first released in what Triton called backends. These are basically plugins for Triton that will support PyTorch or TensorFlow or this or that. So in my experiences, I've noticed there is roughly like a month and a half lag in between the time when that feature is made available in the backend on GitHub, and then shipped on a official Triton container. But that's not the end of the journey, because then you'll have to wait until AWS SageMaker team will update their supported container versions, and this again takes quite some time. Could be, I've seen in some cases it could be up to 6 months. So in fact, there is a solution for shipping runtime in more in a quicker manner, but that feature will have to go through these stages for you to be able to use it in SageMaker. And you can imagine that once you've developed the whole project with a given version, then it's not very easy to sort of upgrade the whole stack throughout, because it's fairly complex to handle in the NVIDIA drivers mostly. So it's not just as easy as just flipping a switch. So in brief, we've seen so we've seen Triton and SageMaker, and I would say the problem I think with these tools is that they require a lot of MLOps steps, especially manual steps and setup. So it is I think the industry will really benefit from adding a lot of automation there in the near future. But on the other hand, this combination of NVIDIA technologies and AWS proved to be very compatible with, we use PyTorch, but there is a variety of ML frameworks supported, but it's very easy to scale basically, and it performs very well. So in that sense, here's your trade-off. But in that sense, it's proven to be stable, and very stable, and well performing. So I would happily recommend using the same stack to anybody that is interested in deploying this type of generative AI models. So that's all from me.
Awesome. Thanks, Enrico. So yeah, if anybody has got any questions, then please feel free to ask them in the chat window, and I'll relay them through to Enrico. I've got a couple questions myself that I noted down. I didn't want to interrupt your flow. The first one was, you had an asterisk on a slide when you were talking about the Conda packaging for Triton. What do you mean by disaster recovery risk unless mirrored? What do you mean by that?
So this has to do with so I didn't mention in the talk directly, because it's not a problem with Triton per se, but when you're when you're deploying such a project, you're essentially, and you're relying on third parties libraries. So in the screen we'll see like PyLoudNorm, or others. So these are pulled from the internet, essentially from public repositories, and it may happen for whatever reason that they get removed from, or these repositories may become unavailable at times for a variety of reasons, and this could be a problem in the case you're facing a disaster. You're trying to recover, and you'll, in the midst of your disaster recovery, you find out that this package or that package is no longer available on PyPI. It's very unlikely. But yeah, let's say it's not very unlikely. It could also be removed by the authors, and or that version could be yanked at some point. And this could happen with sort of early stage open source small projects. So what I said, so the bottom of the screen, it says unless mirrored, is that at some point we sort of faced the need or desire to come up with an internal mirror for our packages. So this will make us resilient against, this disaster scenario that I mentioned, but also you can imagine also for performance. I mean, whenever, like, if you bring in a lot of, hopefully one day you bring in a lot of automation in the building process. So pulling all these packages over the wire will also take some time. And at some point, basically, you want to have your internal mirror for your packages.
Sorry, just to jump in, just to get my understanding correct. So this is a problem with the particular setup, because you're not using a container image to actually host the runtime. This is actually being rebuilt every time a SageMaker instance starts. Is that right?
It is whenever you build a bundle. So so SageMaker picks up a bundle from S3. So you're going to face that problem possibly when you're at this stage.
Yeah. Okay. Right. Okay. So you do have a fairly static artifact there that should be rather safe to use, if you're trying to recover. But yeah, okay. Appreciate the risk. Yes,
although I would like to mention that so we've seen also with some machine learning libraries may not come as self-contained packages, and they will pull artifacts sort of on demand.
Right.
And that happens in the case that you mentioned. So SageMaker spins up your Triton model, and then it will, so in the boot phase, will just pull this package from the repository. So that also is sort of a risk point.
Yeah. Okay. So the solution there is to attempt to bake whatever dependencies are required into the build process as well. So how do you do that with Triton then? Do you have to write like a special script to kind of pre-pull all of those things down and then put it in the bundle?
Possibly. I think that's sort of the most, I would say, stable, proven solution would just be to run your private a package repository. You'll have full control over it. You'll run it next to your cloud, like within your cloud zone, and then you're like, at that point you're very safe to go.
Okay, interesting. Thank you. You mentioned something about the CI, or the fact that it was really hard to do the CI, and you kind of said that that's still a future to do. Like, so how would you tackle that problem if you can't create like a easily reproducible environment? Is it like, are you going to have to run like a full shadow system where you can kind of, use it in like a staging environment and just test it there, or are there any kind of other ways that you've seen?
Yeah, it's let's say, well, I don't have a straight answer for that, but basically, so the problem, and this could be like a topic for a whole new talk, but basically, if you were to write a compatibility matrix for your Triton, SageMaker supported containers, NVIDIA supported drivers by this or that machine, in your Python version, remember Triton has a Python a backend that supports, well, a variety of Python versions, but not all of them, and so on. So if you were to sort of conceive such a requirement, it wouldn't be a matrix. It will be sort of a multi-dimensional entity, and it's so currently, I think, with a given, well, it's current technology, it's really hard to sort of you have to find basically like a path throughout this multi-dimensional space that works and is stable enough for you. So I think we're not there yet, and I think there is a lot of well, there is research and you will have to do before you get to deployment phase.
Yep. Okay.
Yep. So it's I think it's an unsolved problem still.
Yeah, I mean, yeah. So personally, my view is like the only way you can do it then is with a full-on replicated environment that shadows the production system, and you can just deploy your stuff to there and then run some tests on that as if it was like a real system. But obviously that gets really expensive and complicated because you've got multiple people trying to push multiple things at the same time. Okay, cool. Do you have any like opinions on how cost-effective SageMaker has been? Do you have any sort of opinions on like how it would compare to using another provider?
Well, it is very expensive. Well, you're going to pay for, and it's likely more expensive than most providers out there.
Right.
You are going to pay for, the wealth of features you have access to, and the auto scale, as well. But it's definitely not a cost-effective platform to run on. That will guarantee.
Yeah. Okay, fair enough. All right, cool. That's the last of my questions then. We did have one sort of thank you comment that came in, so that's nice to hear. Thank you for that. I think, but we'll leave it there. So if anybody has any further questions, if you didn't have time to ask them, then feel free to email us at phil@winder.ai or enrico@winder.ai. We'll be happy to answer those questions. We'll publish this video and the slides up to the website shortly. But for now, I think we'll call it a day. So, yeah, thanks a lot. Appreciate your time, and I'll see you next time. Thank you. Bye-bye.